Here's how to understand the chain rule in calculus. So when taking derivatives, sometimes you'll run into complicated functions like this one. One way to do this would be to FOIL the entire expression out, and then do the power rule on each term. But as you can see, this gets stupid messy when dealing with higher exponents. A better way to tackle this derivative is by using the chain rule, which I'm sure you've seen described as this fancy math equation, which can be kind of scary. But don't worry, here's a trick to make it easy. Anytime you see a messy expression and have to take a derivative, try to think what would make the derivative easier and replace it with a box. In this example, I don't know how to do the derivative of 4x squared plus 3 all to the fifth, but I do know the derivative of something to the fifth is just 5 times that something to the fourth. Thanks, power rule. So here we're going to replace the 4x squared plus 3 with a box, and then just take the derivative. This is a lot easier and just gives us 5 times that box to the fourth. Now everything comes with a price, and the price we have to pay for using this trick is we must also multiply our answer by the derivative of what's inside the box. In this case, it's pretty easy since the derivative of 4x squared plus 3 is just 8x. The last step is to plug back in the 4x squared plus 3 for the box, and you're done. Note that what we just did is the same as the formal math definition for the chain rule. Here we found the derivative of y with respect to x by first finding the derivative of y with boxes, and then multiplying by the derivative of what was inside the box with x's. Now let's make it a little harder. Sometimes you're going to run into even more complicated expressions that require double or triple chain rules. But don't worry, the process is still the same. You just have to start at the outermost operation and keep track of how deep in the chain you are. Let's try taking the derivative of sine cubed of 10x squared. For these types of trig functions, I like to rewrite sine cubed as the sine of 10x squared all to the third. This makes it easier to see where the outermost operation is. In this case, we see that life would be a lot easier if we were just taking the derivative of something to the third. So I'm going to call my box the sine of 10x squared, and then take the derivative. This gives us 3 times the box to the second, which after plugging back in will be 3 sine squared of 10x squared. But don't forget, we still need to multiply by what the derivative of inside the box was. In this case, taking the derivative of inside the box isn't so simple, as I also don't know how to do the derivative of sine of 10x squared. However, I do know that the derivative of the sine of something is just the cosine of something. So here I'm going to call the 10x squared my new box, and take the derivative of sine of box, which just gives me the cosine of box. Now plug 10x squared back in, but don't forget we still have to multiply by the derivative of our new box. And luckily the derivative of 10x squared is easy, and just becomes 20x. So all that's left to do is bring everything together and combine some terms, which gives us our final answer below. Also note how using these nested boxes is the same as using the formal chain rule definition. In this case, you just have to add another level to the chain. But in the end, it all still cancels out to dy over dx. And there you have it. That's how to use the chain rule in calculus.
Nice!